The cheapest maintenance activity you will ever perform costs roughly 500 pesos. A simple bearing inspection, a lubrication check, a filter replacement. Allow that exact same component to run until it catastrophically fails, and the repair averages 52,000 pesos in parts and labor alone. When a machine locks up on the factory floor, the financial damage extends far beyond the broken part. Your maintenance team spends up to 4 hours just diagnosing the fault. Production halts while you check inventory. If the parts are not in stock, you wait days. And when they finally arrive, emergency repairs performed under pressure by tired technicians carry a significantly higher rate of incidental damage. This visual breaks down the hourly penalty of that unplanned downtime. Globally, it averages $260,000 an hour. For Philippine manufacturers, you are losing between 80,000 and 500,000 pesos in production value every single hour that line is down. Most plants experience dozens of these events every month. They treat them as the normal cost of manufacturing, but they are a direct result of strategy, and you can change that strategy. The framework we use to map these strategies is based on the Asset Reliability and Maintenance Engineering body of knowledge, the global standard for industrial maintenance. The cost ratios and implementation timelines you are about to see are drawn directly from our experience tracking maintenance budgets in Philippine industrial deployments, both before and after a strategy transition. We know how to eliminate these emergency costs because we have tracked the mathematical reality of this process across multiple manufacturing environments. Reactive maintenance is the strategy of running equipment until it breaks. For non-critical assets with low replacement costs, like a conveyor return roller or a lighting fixture, this is an economically rational approach. But for critical assets, the true financial penalty of reactive maintenance is the collateral damage. This diagram maps out how a small failure cascades. It starts with a 3,000 peso bearing failure inside a motor. That overheating bearing damages the motor windings. The failed motor triggers an emergency stop on the line, which immediately causes a product jam that damages downstream equipment. What began as a cheap mechanical issue has multiplied into a 180,000 peso repair event. To prevent this, facilities adopt time-based preventive maintenance. They schedule interventions at fixed intervals, like replacing a belt every 6 months, which successfully eliminates most of these cascade events. However, scheduled maintenance carries massive hidden costs. The first is overmaintenance. If you replace that belt at 6 months, but it had 4 months of useful life remaining, you have wasted that component. Across a fleet of machines, replacing parts before they wear out often equals the cost of the failures you are trying to prevent. The second hidden cost is the PM dip. Whenever a technician disturbs a machine to replace a part, they introduce the risk of installation defects. Failure rates actually spike in the 48 to 72 hours immediately following a preventive maintenance intervention. Time-based schedules give you predictability, but they are highly inefficient. They are a necessary step away from reactive emergencies, but they are not the ceiling for operational efficiency. Predictive maintenance relies on actual equipment condition rather than a calendar. You monitor the machine and intervene only when the data indicates a repair is needed. By tracking variables like vibration amplitude, you can safely leave a component in service until it reaches the true end of its useful life. Because condition monitoring detects degradation markers weeks in advance, you have ample time to schedule the replacement during a planned outage. No emergency downtime, no collateral damage. Let's look at this matrix comparing the outcomes of the 3 strategies. Under a preventive schedule, component utilization drops to around 60 to 70% because parts are swapped out early. Predictive maintenance pushes that utilization up to 95%. When you eliminate premature replacements and prevent catastrophic failures, predictive programs deliver a 25 to 40% reduction in total maintenance costs compared to preventive models. Moving your operations from calendar dates to condition-based execution recovers the capital you are currently losing to inefficiency. You cannot apply one single maintenance strategy across an entire facility. You map your approach directly to the failure consequences of each machine. This graph illustrates the PF interval. P is the point of potential failure, where a sensor first detects degradation. F is functional failure, where the machine stops working. The gap between them is your planning window. Critical assets like heavy motors and main pumps have a long PF interval, giving you weeks or months of warning. These require predictive industrial IoT sensors to track vibration and temperature. Assets like electronic controls and drives can fail with almost no warning. Because their PF interval is so short, you must rely on preventative strategies like environmental controls and scheduled inspections. In an optimized plant, roughly 20% of your assets will require predictive monitoring, 40% will sit on preventative schedules, and the remaining low-risk assets will run to failure. You focus your expensive sensor investments strictly on that top tier of assets, where avoiding a single failure guarantees your financial return. This timeline shows that transitioning to a predictive model is a methodical process spanning 9 to 18 months. Phase 1 takes 3 to 6 months. You stop the bleeding by organizing your spare parts, establishing basic preventive schedules, and deploying a CMMS to track work orders. In Phase 2, you install condition monitoring sensors on your most critical assets. You connect them to an IoT platform and gather baseline data to establish normal operating ranges. Phase 3 activates the predictive strategy. You set custom alarm thresholds based on your facility's exact environment, and you train your maintenance team to prioritize work orders based on real-time data trends. Executing this roadmap methodically reduces emergency downtime, cutting your total maintenance budget by up to 45% by the end of the transition. A 500 peso inspection versus a 52,000 peso failure. It is the exact same component. The only difference is timing. Take your last 12 months of maintenance work orders and categorize them by strategy. Calculate the total labor and parts spent on reactive repairs. That number represents your immediate opportunity. In our next video, we will detail the specific sensor technologies, like vibration analysis and thermal imaging, that make this transition possible. Subscribe. The maintenance strategy that has been draining your budget is entirely within your power to fix. Your operational costs are not determined by luck. They are a direct output of the strategy you choose to deploy.